Hi. In this video, we'll talk about one feature of the trimmed cell mesher. Let me introduce the example we will use. We'll start with a simple cube model. The cube geometry is very simple. Corner number 1 is at minus 0.5, minus 0.5, minus 0.5. And the opposite corner is at plus 0.5, plus 0.5, plus 0.5. So the cube is 1 meter in every direction. I also defined a region and some boundaries, but that's not the focus. Our focus is meshing, so go to Operations and right-click. Create an automated mesh operation. We'll mesh block 1. Select block 1. The core volume mesher option is not needed here. Choose the trimmed cell mesher, then click OK. Now go to base size. Remember, each cube dimension is 1 meter. I'll start with a base size of 0.2 meters, then run automated mesh. I already prepared a mesh scene. Open it now. With this base size, notice what happens. At the far ends, the mesh cells change size. The end cells are different from the core cells in the middle. This happens because the trimmed mesher has a feature called mesh alignment. Inside the trimmed cell mesher, there is an option called Perform Mesh Alignment. If Perform Mesh Alignment is disabled, the mesher always aligns the grid using the global origin at 0, 0, 0, unless you specify a different alignment point. Now let's change the base size. I'll set it to 0.1 and run again. With 0.1, the mesh looks much more uniform. So here the alignment effect is basically gone. But with other sizes, like 0.2 or 0.15, it becomes visible. For example, with 0.15, the mesh is uniform in the center. But as we get closer to the corners, the cell sizes change. To control this behavior, you can enable Perform Mesh Alignment. As the tooltip says, it aligns the mesh relative to a chosen point. This helps you align your grid with a specific reference location. I enable it now, and a new field becomes available. This new field is Mesh Alignment Location, and by default it is 0, 0, 0. If I change it, remember the corner coordinates are minus 0.5, minus 0.5, minus 0.5. So I enter minus 0.5 here. As I change the coordinates, the highlighted point moves. This is the point I want to use as the mesh alignment reference. I want STAR-CCM Plus to treat this point as the origin for the trimmer grid. Now click Execute. Now we can understand the effect in X and Y. Let me turn off projection mode. This point is now on the corner, so the trimmer starts from here. When it reaches the far ends in X and Y, the last trimmed cells change size. If we look in the negative Z direction, the same idea applies. The grid starts from the reference point and trims near the Z extremes. So the boundary cell size changes where trimming happens. So why does this matter? Because mesh alignment lets us control cell sizing near important boundaries. It helps us place the trimmed cells where they are less harmful. Here, in X and Y, cells are uniform from this point. But in Z, near the boundary, the cells become smaller. Now let's consider another case. Assume we have 2 blocks instead of 1. And the 2 blocks are placed next to each other. First, let me delete the current region. Delete it, then select both parts together. Right-click and choose Assign Parts to Regions, and create boundaries for all faces. Click OK. Now the region is created. Back in the mesh operation, also select Block 2. Now both blocks are selected. Here is an important note. With 2 parts in one region, the default mesher may fail. So you often need to enable an option called per-part meshing. We'll do that, but first let me update the mesh scene settings. In the scene, go to Surface Part. Enable Part Display and show the region surfaces. Now the parts become visible. If you still don't see it, change the representation. Now the parts are selected. Now execute Automated Mesh. You can see an error. It says it cannot find a proper direction and orientation for the surface. So click Per-part Meshing. And disable Mesh Alignment for now. We want to see the default behavior first. Click Execute. Now update the mesh scene. Let me restore the view to the original mode. One small educational note here. In the geometry scene, you may see only one block, even though both blocks were selected in the part list. The reason is the representation is set to geometry. But block 2 was moved by an operation like transform. I moved block 2 using a transform operation. So in geometry representation, you still see the original default state. Change the representation to lattice surface. Then STAR-CCM Plus includes all surface operations. Now you can see the final geometry. This is the geometry we have, and this is the mesh that was created. We also talked about the small coordinate triad and the fast view clicks. If you click a plane, the camera becomes normal to that plane. And if you click an axis arrow, you can rotate by an exact angle. Let me show it quickly. Click an axis arrow, and a window opens for the rotation angle. For example, rotate 45 degrees in Y. Or rotate 60 degrees. You can see the view change. Now I'll return to the original view. Now, with the default mesh, the interface between these two parts is not aligned. So if you create an interface or contact between these surfaces, the data transfer can introduce errors. One solution is to align both parts to the same mesh reference point. Go back to the trimmed cell mesher and enable Perform Mesh Alignment. Then set mesh alignment location wherever you want. And align the mesh based on that point. But notice, this option is not available per part when per-part meshing is enabled. Because with per-part meshing, each part is meshed around its own center. That is why, when you look from the front, Block 1 uses its own center as the alignment origin. And Block 2 uses its own center as well. But when you disable per-part meshing and use mesh alignment location, both parts use the same coordinates as the alignment reference. So all the cells align in that direction. Click Execute. Now you can see the mesh is aligned to that point. The vertices match much better across the interface. So the interface or contact becomes more accurate and stable. You can also test different alignment locations. For example, use the center of Block 1 at 0, 0, 0. And see what happens. As you see, for contact quality, the exact location is not the main point. The key is that you choose one alignment location. And STAR-CCM Plus uses it for all parts. That is what creates aligned contacts at the interface. So the contacts you build are much cleaner. I hope this tip and this short training was useful. Use mesh alignment with the trimmed cell mesher. Good luck, and see you in the next video.